Okay, so we were doing the difference quotient, which I told you right now that you don't have to memorize what the difference quotient is yet. Eventually it will be really quick and you will know it. Right now, you just have to be able to do the algebra to simplify the stuff that shows up when we do the difference quotient. So, and remember, you might have grabbed an extra sheet of paper because I did not leave you very much room on that notes handout, my bad. So, f of a plus h, what would that be in this case?
-3 over a plus h.
Minus f of a, so minus -3 over f, all divided by h. Alright, so if you're one of those people that hates fractions, you might have a little anxiety going on right now because we have fractions within a fraction. It's all nice and beautiful. What do we have to have in order to be able to add or subtract with fractions? Common denominator. Okay, and then how do you divide with fractions? Flip and multiply. So that's a lot, isn't it? Do you want a shortcut? Okay. We know in a fraction, it's legal if you do the same thing on top and bottom, right? Like if I multiply the top by 2 and the bottom by 2.
Yeah, why is there an x? Is that an a?
Yes.
Okay, sorry. I just wasn't trying to point you out, but I was really confused on why there was an x.
Okay. So minus a negative, could I just go ahead and make that a positive right there?
Yeah.
Okay. So we can do the same thing on top and bottom. So what I am going to do, I'm going to multiply the top by a plus h and a. So I have to multiply the bottom by both. Here's why that helps. When you distribute that to each term on the top, what happens in the first term? A plus h cancels, so you're left with negative 3a. Plus, the next term we have 3. The a's cancel, so it's times a plus h. And on the bottom we just have all this stuff. We can write it in any order, so I'm going to write a times h times a plus h. So if we distribute, we get negative 3a plus 3a plus 3h. What happens? What else happens? So we get 3 over a times a plus h. And you could distribute that if you wanted to make it a squared plus ah. Doesn't matter. What do we got there? So we've reviewed some of looking at the graphs of a function, reading the graphs, function notation, simplifying with those in our difference quotient. What kind of function is this? I don't remember the name for that. Starts with a P. It's piecewise, because there's more than one piece.
How did you get? I was thinking of pairwise and then
Okay, so if I ask for f of negative 2, we know if it's a function, we can only get one answer out, so I can't put it into both of these pieces. So what do? In the one it fits. So our rules, we do the top piece if x is less than or equal to -1, Second one if x is greater than -1. So -2 is less than -1. So we plug it in there. So 1 minus -2, which is 3. F of -1, which piece do you plug it into? Top. So 1 minus -1. F of 0, which piece? So 0 squared is 0. Okay, then I asked for a graph, just because it's fun. We use graphs a lot in here to help us with things. That is kind of crooked. How do we graph piecewise functions? You started back in algebra 2. We did some more college algebra. We had 2 pieces, so what did we have to do? 2 t-charts. Okay, so the first piece has to start with -1, and then we need things less than that. So maybe -2 and -3. So if we put in -1, we got out 2. We already figured that out. If we put in -2, we get out 3. -3, so 1 minus -3 is 4. So let's plot that. -1, 2. -2, 3. Okay. When we go to do the second one, what do we have to do? You still have to put in -1 for your starting point, but since it wasn't equal to that, it's open. Then we need things greater than -1, so maybe 0 and 1. So -1 squared is +1, 0 squared is 0, 1 squared is 1. So -1, 1, open, 0, 0, 1, 1. If you wanted more points, you could put in a 2, 2, 4. So what we're getting is part of a parabola. It starts here, and then it continues that direction. Notice it's a function, so it has to pass the vertical line test. Alright. Is that okay with everybody? Last thing I want to talk about with functions would be our domain rules. We have certain types of functions that have restricted domains. If I am looking at a fraction, what do you know about the domain of the fraction? If I said like 5 over x, what can x not be? 0. So in a fraction, the denominator cannot be 0. Okay, radicals. It's only certain ones. It's the even radicals. So like square root, fourth root, sixth root, so on. What can't happen? So the radicand, or the thing under the radical, has to be greater than or equal to 0. So if it's an even root, you cannot have a negative underneath. All right, the last one wasn't one that we focused on as much because it didn't appear until the end of the year. And then log. It's been a while. What can't you take the log of? Oh, such a failure. What did I do wrong? Okay, let's have a little crash course. At the end of college algebra.
I wasn't in college algebra.
Or the end of pre-calculus
all of
algebra.
it.
Okay, so if I said like an exponential, y equals 2 to the x. You guys know what that looks like, right? 2 to the 0 power is 1. So we had 2 to the first is 2, 2 cubed is 8, 2 to the negative 1 is 1/2. That's an exponential. You guys remember those? Okay. So a log is the inverse of an exponential. So it's like saying you flip the x and y essentially. So when I see log base 2 of y, if I said like log base 2 of 8, what that means is 2 to what power equals 8? Okay, if I said log base 2 of 1/2, 2 to what power equals 1/2? So because it's the inverse of the log, what happens is the points on the graph just get flipped. So this is the point 0, 1, so it goes to 1, 0. This is the point 1, 2, so it goes to 2, 1. This was negative 1, 1/2, so it goes to 1/2, negative 1. And that's what the graph of the log looks like. So what's the domain of this? Does it ever cross this line? So it's just 0 to infinity. So a log, the argument, the thing we're doing the log of, has to be greater than 0. You can't have, we have a vertical asymptote there on the y-axis, so it has to be strictly greater than 0. All right, so I'm going to give us some functions and we're going to see if we can find the domain of each. Okay. So for A, it's a square root, so what does that mean? Can't be negative. So the x plus 2 has to be greater than or equal to 0. So x has to be greater than or equal to negative 2. How do we write that? Interval notation?
Is that with the U?
Mm-hmm.
Oh,
bracket.
a negative 2 to 0.
Well, it's just strictly greater than, so it can be anything bigger than negative 2.
So, no.
Starts at negative 2 and goes
And
forever.
then it goes to infinity. Something tells me. And you have the funny little U.
Negative 2 to infinity. Sometimes we had to use when we had more than one.
If it goes further.
Mhm.
It's usually a closed bracket to another.
Yeah. So we have a starting and a stopping point when we do the interval. All right, B. We have a fraction. And a fraction, what do you know? The denominator cannot be 0. How am I going to figure out what makes that equal 0?
Set it equal to 0.
Mm-hmm. And then what?
So you can't do like infinity.
I need to solve for x here first.
Can you take out?
Take out an x. That leaves us with x minus 1. So x cannot be what?
0.
Or 1. Remember in your previous math classes, if it was more than one value x couldn't be, I did let you just list them like this. If it was only one value, I did want the interval. So if it were just x can't be 0, I would expect you to write negative infinity to 0, union 0 to infinity. If you wanted to do the interval on this one, it would be negative infinity to 0, union 0 to 1, union 1 to infinity. But I wouldn't require that if you have more than one value that x can't equal. C. I don't see a fraction. I don't see a radical. I don't see a log. So what's my domain? D. Okay, I've got a couple things. I have a fraction, so what can x not be? Okay. I have a cube root. Do I have to worry about cube roots? No. So since it's just one value x can't be, we could do the interval. So it's negative infinity to 0, union 0 to infinity. E. We have a fraction, so what does that mean? Bottom cannot be 0, so if I factor that, what does that factor into?
6 and 4 and 3.
So x cannot be
Negative
3 or negative 4. Okay, F, I have a log. What did I say about the log? Okay, so the argument, that's the same thing in the parentheses, greater than 0. So 2x is greater than negative 5. So x is greater than negative 5 halves. How do I write that?